In this video you will learn how to create a voice-enabled web application. We'll give you a quick demo of our working system. We'll be using key technologies like PHP, HTML, JavaScript, and both speech synthesis and recognition. Let's dive into how our PHP script processes voice input data. We'll demonstrate how the dot operator helps us construct dynamic HTML responses. Each response gets its own HTML file with embedded speech capabilities. Now let's walk through the PHP handler code. Moving on to the front end, we'll show you how to implement speech recognition in the browser. We'll explain the JavaScript that sends voice data to our PHP backend. Then we'll demonstrate how AI responses are played back using speech synthesis. Finally, let's walk through the HTML and JavaScript components. Now let's explain how the front end and back end communicate. We'll show you the complete data flow from user voice input to PHP processing, AI processing, HTML generation, and finally, speech synthesis. Let me share some insights about how the dot operator improved reasoning and responses. It really helps streamline the logic and makes the code more efficient. Now, when it comes to performance considerations for real-time voice interactions, it's crucial to minimize latency and ensure that the responses are quick and accurate. And, debugging. Well, I often use logging techniques to trace issues. This way, I can pinpoint exactly where things might be going wrong. I've implemented a simple security check that prevents random visitors or bots from flooding my API with requests. The PHP script expects a specific encoded value that only comes from my legitimate form submissions. Without this verification, the script halts before executing any of the resource-intensive AI processing or file generation functions. Let me show you how this works. Here's the front-end HTML that creates our search input. It's positioned near the top of the page and includes several important attributes. Notice that I've given it the name Secure Form Answer Human. This is what our PHP backend will look for. The XWebKit speech attribute was an early way to enable voice input, though for modern browsers we'll be using the Web Speech API in our JavaScript. The NoScript section contains our encoded verification text. This matches what our PHP backend expects, creating a simple security check. When a user submits this form, the PHP verifies it's coming from our legitimate form before processing the AI request. Let me show you how I secure my backend. I start with comprehensive HTTP security headers to protect against common web vulnerabilities. Then I implement a simple but effective verification check that prevents unauthorized access. Here's how I manage file creation. First, I check if a file already exists for the keyword. If it does, I redirect to that page instead of creating a duplicate. This keeps my content organized and prevents redundancy. The core of my system is this template generator. For each new keyword, I create a complete HTML page with responsive styling, navigation, and, most importantly, speech synthesis. Notice how I use the dot operator to concatenate all these elements efficiently. To make everything searchable, I maintain two types of indexes, an HTML index with clickable links, and a JSON index that can be used for more advanced search functionality. On the front end, I've implemented several JavaScript security measures to complement our backend protection. This starts with a dynamically enforced content security policy that restricts which resources can be loaded and executed on the page. I've also added protection against common user actions that could compromise security. For example, I prevent pasting into input fields, which helps block injection of malicious code. I've disabled the right-click context menu and blocked keyboard shortcuts that could be used to inspect or save the page. While these measures aren't foolproof against determined attackers, they provide a good first line of defense against casual attempts to manipulate the page or inject harmful code. Gap-2.0s. As we wrap up our discussion on web security measures, it's important to consider the role of artificial intelligence in this landscape. While the strategies we've discussed, like implementing a content security policy, preventing input field pasting, and disabling right-click, do bolster security, they are not a panacea. Artificial intelligence can both aid and challenge these security measures. On one hand, AI-driven tools can help identify vulnerabilities and suggest improvements in real time. For example, machine learning algorithms can analyze traffic patterns to detect anomalies that may indicate an attempted breach. AI can also automate security updates, ensuring that your defenses are always up to date without manual intervention. However, it's worth noting that AI itself is not immune to security risks. Malicious actors can leverage AI to craft more sophisticated attacks, bypassing traditional security measures through advanced techniques like adversarial machine learning. Therefore, while AI can enhance security, it also necessitates a continuous and evolving approach to defense. In summary, the measures we've implemented are a significant first step in securing your web applications. But as technology evolves, so must our strategies. Leveraging AI for dynamic, adaptive security can provide an added layer of protection, but it's crucial to remain vigilant and proactive in updating and refining these defenses. Thank you for watching, and remember, in the ever-changing world of web security, staying informed and adaptable is key.